Hey, Rick Usabel again from Cabaret Design Group, talking today about long draw draft beer system design. Hello again, everyone, and welcome to another edition of Design Buzz. Today we're going to talk about long draw draft beer system design. And when we talk about long draw draft beer systems, we're talking about systems that operate remotely from the bar, unlike a direct draw cooler, which sits below the bar or directly behind the bar, as we covered in two previous videos. The long draw systems basically operate from a walk-in cooler, and at the more basic level, the traditional concept that was delivered for a long draw system was the system known as an air-cooled system, shown here in this blue dotted line. We also have what's called a glycol system, which we'll be covering in another subsequent video. Now, with the air-cooled systems, the process begins in the walk-in cooler. Now, these systems really basically work off of a mechanical blower, which is rely on totally to keep the integrity and the temperature of the beer within its operating range from the point where the beer originates in the walk-in cooler to the point where it's dispensed. Now, the air-cooled system is, the heart of it is basically not only the walk-in cooler, but we also have what's known as a beer shaft. The shaft is really nothing more than an aluminum conduit, several inches in diameter, which will house a number of small diameter PVC lines, each one connected to a different brand of beer inside the walk-in cooler. In this particular arrangement here, we see this device over here is our blower motor mounted inside the wall of the walk-in cooler, and this blows the cold air from the walk-in cooler along the length of the beer shaft. Now, we're relying on the integrity of the temperature of the beer to be maintained. Walk-in coolers normally operate within the range of 36 to 38 degrees Fahrenheit. This is what is specified by the people who manufacture the beer. This gives an optimal flavor to the beer, and so it's generally recommended that you maintain your walk-in cooler within that range. Air-cooled systems are generally specified by the manufacturers of the equipment to operate at no more than, say, 25 feet. This particular system, as I've designated here, is about 60 lineal feet as the crow flies, which is a little bit more than 18 meters. Now, right at this juncture, you could say to yourself, this is not an application for an air-cooled system. This is true. I'm showing you the idea as an example, because we're going to be talking about the glycol systems next. We could alternatively move the walk-in cooler conceivably to the area where the office is shown here, and if that's the case, we would be within several feet of the tower from the walk-in cooler. So we're within striking range, let's say. If this is, say, 10 feet or 12 feet, whatever we have, there are two constraints that really sort of dictate the success of a air-cooled draft beer system. Number one, every 90-degree turn that the beer shaft takes, once it leaves the walk-in cooler, you lose 5 feet of functional length. The longest normal length that you would consider for such a system would be 25. So if you have one 90-degree turn, that's already bumps you down to 20 feet or less. Now, ordinarily, these systems would be delivered from the walk-in cooler either overhead or below the floor. And then if that's the case, then your draft beer shaft would be running below the floor. It would come up directly below the tower, and then you would be delivering the beer. Now, the other problem, though, that's not printed, design constraint that will commonly be experienced in a air-cooled system, is that for every 90-degree turn you take with the shaft, you're going to gain 2 degrees Fahrenheit in temperature in the product. So this starts to create huge problems because we don't really have many ways of adjusting this temperature. You don't have anything else except for the cooling of the walk-in cooler itself and a crafty installer to try to make it all work. Even in short distance, it's a challenge. Ideally, an air-cooled system would be installed this way. You would take your walk-in cooler, and let's say if this bar is on the first floor, if you had a basement in your building, the walk-in cooler would ideally go directly below the bar so that you could run your beer shaft and you're pushing the air vertically through a column up to the tower. Then you start to accumulate warm air at the base of the tower. So you really have to also have a means of recirculating that air and bring it back into the walk-in cooler so that you maintain a constant flow of chilled air to the tower. Now, the towers for air-cooled systems are different from the towers that we're using that you may be seeing nowadays, the very cool towers that you see in most modern bars and nightclubs and brew pubs and places like that. You're not looking at a air-cooled tower, most likely. The reason for that is that you have to have a large diameter tower so that the air can recirculate. This is a pronounced difference between air-cooled towers and the glycol-cooled towers. So you have, generally speaking, a narrower range of tower selection for air-cooled systems. Air-cooled systems are basically entry-level systems. In my book, they are really sort of, I would say their popularity is definitely waning now that we have the glycol systems at our disposal. Although, so, you know, you can still get into a system like this fairly reasonably. There'd be many factors. If you're going to have dispense, say, 8 brands of beer, you might be in the range of several $1,000s for an installed system. The real solution for a long draw draft beer arrangement is with a glycol system, and we will be covering in the next video.